Okay, quiet please. Quiet please. So we went over these slides already. This is all what we did yesterday, right? And I think we got to the part, we even did that. Now, one thing I wanted to add, because this is gonna actually be something that when we get to the next lesson, which is going to be a review of addition, okay? And you're going to say, I know addition, I know how to do that. It's mostly about adding positive and negative numbers and, you know, how they work against each other sometimes. But it's also, they're going to throw in there decimals and fractions. And when we do this and when we test on this, that's going to be without a calculator. I mean, you need to know how to add fractions. You need to know how to work with decimals. And so I want to just show this thing which actually does involve decimals, maybe to remind you a little bit. But let's say we said that a non-terminating decimal, as long as it breaks into a pattern, can be written as a fraction, right? So let's just say, I'm going to give myself a repeating decimal, right? What does it mean if I say 0.123 and I put a bar over the 123? Lily? Yeah, it means that those three numbers go on forever, right? So after that 1, 2, 3, there's another 1, 2, 3, and another 1, 2, 3, and another 1, 2, 3. Okay. So let's just say, and this is using just a teeny little bit of algebra here, but we know a little bit of it. Let's just say that my x equals 0.123. Okay. How could I move the decimal place over 3? What would I have to multiply this by so that the decimal place moves over 1, 2, 3? Julian? 3 decimal places makes it 1,000, right? 10 moves it over 1, 100 moves it over twice, 1,000 moves it over 3 spaces. So then I'm going to put on top of that 1,000 times x equals, and if I move that over 3 places, what I've got now is 123.123 repeating, right? By multiplying by 1,000, I just made this number, you know, by moving that over, now it's 123, then the decimal point, and then the repeating, okay? Now subtract. What would you think is 1,000x minus 1x? 999x, right? Okay, what do you think happens when you subtract 123.123 repeating minus 0.123 repeating? Not 0, but these cancel. If I subtract, these cancel. All that's going to be left is 123, right? When I subtract 123 plus 0.123 minus 0.123, the 0.123's cancel. And all I'm left with is a whole number, 123. And if I divide that by 999, I have a fraction. And that may be just a little beyond what you remember, but that's how you turn repeating decimals that are non-terminating, that actually they can be written as fractions, and that's how you do it. I mean, if you could put this in your calculator right now, 123 divided by 999. What's that? Okay, so then you could reduce it. Good. So if you do that, you should get the 0.123. I mean, I could tell you that most people, I bet you, even a lot of math teachers wouldn't show you that. But decimals we're going to have to work with. So let's keep going. I think we did a little bit after that, right? We had to classify numbers as being whole, rational, or integer. Actually, we talked about 2 other sets of numbers. What were these 2 other sets? Jillian? Irrational, great. And natural, the counting numbers, you know, the ones that are the most natural. Okay. And so we did all that. And so now this is what we didn't do. Okay. This is the first one we didn't do. It's slide 14 out of 21. This is a word problem from the book. A star's color index is a measure of the temperature of the star. The greater the color index, the cooler the star. Order the stars from hottest to coolest using that number line. So where would I graph? Let's start with Eneb, 0.21. Does it go to the right of 0 or to the left of 0? Okay, and so I see 0.2. I don't see 0.21. Where would I place 0.21? Okay, about like right there, right? But okay, and so that would be Eneb. Okay, how about Shaula? Negative 0.22. Left or right? Negative numbers to the left. Okay, does it go a little bit to the right of negative 0.2? It goes to the left, right? Because it's, remember that as the numbers get bigger negatively, they go to the left. So that would be right here. I'll put that with an S. Okay, how about negative 0.003? Okay, how far should I go? Should I go like halfway? I mean, halfway would be like 0.05. So where would be 0.03? How about right there? That's the Rigel. And then the Denebula. 0.09. What number is that close to? 0.10. So that would be right there. So there's the Denebula. So they're saying the greater the color index, the cooler the star. So I guess that means the negative color index means it's hotter. So this is the hottest star. And this is the coolest. Okay. So what's that? Okay, so now we get a couple more concepts we got to get down, right? What do you mean by the opposite of a number? Right? The opposite of a number has the opposite sign, right? So a positive becomes a negative, and a negative becomes a positive. So, like if this is 4, right? Negative 4 is the opposite of 4. So when you put a negative in front, that's like an opposite sign. So the negative 4 comes over here, negative 4. So they're the same distance from 0, but they're on opposite sides. What's the opposite of negative 4? Positive 4, right? They're opposites of each other. Okay, and whenever you see a negative in front, okay, whenever you see a negative in front, you got to be thinking the opposite. Yes. Okay, you're right. I will fix that. He's paying attention there. So this is with numbers. And with numbers, you all get it very easily. But when we start working with variables, when you put a negative in front, that doesn't mean that it's a negative number. That means it's the opposite of whatever that value is. Sometimes if the number already is negative, that's actually flipping it to positive. So always think of it as, the opposite. That was wrong. Okay, so find the opposites. If A is negative 2.5, then negative A means the opposite of A. That would be plus 2.5, right? I don't need a plus sign, but I'm going to throw it in there. And if A is 3/4 positive, then negative A is negative 3/4. Okay, the absolute value of a number is the distance from 0 on the number line. So distances are always positive. Like if you're going to drive, who's got family up like by New York? Anybody? Who's got family like down by Florida, South Carolina? Okay, so if you know the distance from here to there, it's always a positive distance. Right? Whenever you're saying how far is something from something else, it's always positive. So on a number line, let's just say, well, let me go back to the last number line that I put up there. The distance from negative 4 to 0 is 4. The distance from 4 to 0 is 4, because you always take those as positive. How far is it from the middle? And so therefore, when you take absolute value of a positive number, you get a positive number, right? When you take the absolute value of a negative number, you get a positive number. So see, the absolute value of 2 equals 2. The absolute value of negative 2 equals 2. Okay, I should have said these straight brackets, those are the absolute value symbols. Yes. Okay, good. So she said, what would that value be if we also put a negative out here? That means you would have to put a negative in front of that. That would be a negative 2. It's a good question. Okay, and then what, by definition, what is the absolute value of 0? It's the distance from 0 on the number line. It's 0, right? Okay, so this is the way that they word the problems in the homework. So this is the way I worded it here. They give you a value, right, 2/3, and it says find opposite of A, find A, or sorry, here's A, find the opposite of A, that's why they put the negative in front, and the absolute value of A, right? So what would be the opposite of A? Negative 2/3, so negative A equals negative 2/3. And what would be the absolute value of A? Positive 2/3. Remember, absolute value is always positive. Okay, how about the next one? If A is 3.2, what is the opposite of A? What did I do here? Okay, right. Negative A equals negative 3.2, and the absolute value of A equals 3.2. Should have had a negative in there. Okay, so have you already seen absolute value before? You did. So that's not new. So try these two. This is your you try. Classwork. Chop, chop. You could just tell me if you want. So negative A is negative 5.3. What about the absolute value of A? Is 5.3. And negative A, when A is negative 7, negative A is positive 7. And the absolute value of A is 7, because always has to be positive. That's it. So that's the homework